Good afternoon, my name is Terrell Henry. This is oral template number 11, section chapter 11, energy carries electricity and hydrogen. And for my first section of the chapter, we're going to start with section electricity, electrification, the climate, imperative, the electric power grid, beginnings, volts, amps, ohms, watts. And for the main point of the section, there is a variety of ways that different places get their electricity. And for an example for that is that the way that different places get their energy and electricity will depend on their location and their different policies. So, for example, a place where you see heavy, where they're very heavy favorited in fossil fuels, where they're able to get those resources, you would see more of the fossil fuels used for getting their electricity, and just using coal and oil and different things like that. Where if you go to a different place where you don't have as many fossil fuels, you're not as lucky as those other places where you're able to get your hands on those, you would probably see somewhere using solar power, or just a different method than being able to use fossil fuel, because everybody's going to need the electricity and energy, so you're going to have to find it one way or another. So to go along with this, since there's different ways to get energy, so like using fossil fuels for one example, and then using solar energy as another example, then you're going to see a difference in the pollution, the carbon emitted in the air, the uses of fossil fuels. You'll see a difference just simply because there are different places that have certain things that a place may not, and a different place where a place may have it. So there will just be different emissions in the air, and it won't all be the same. And for my next section, I'm going to go to section electricity again, the modern grid, electricity immediacy. And for the main point of that section, I have the grid is useful in many ways. And one of the main ways that the grid is useful is the book had a great explanation about it. So when dealing with a light switch, it used, for example, when you turn the light switch off, where is that energy going? You can't just pull energy from anywhere. So the grid is able to store the energy. So that is how our light switches work, is because the grid's able to store that energy for us, and able to help with our electricity, and not having to always leave our lights on, and or always having to leave TVs plugged in, or just different things like that have to deal with electricity. So overall, it goes to help us save electricity. And for my next section, I'm going to go to section science meets policy, Texas troubles. And for this main point, I have Texas's weather costs the state millions and millions of dollars. So to get into this a little bit, I believe it was somewhere in North Texas. I believe it was, and it was, I don't remember the year, but overall I remember that they had their coldest weather that they've ever had in the history of North Texas. So with the coldest weather they've ever had in North Texas, obviously you're going to use more heaters and just different things to heat up your homes. So where this happened, the I believe they said in 2 days it was the highest electricity ever used of all time, just within 2 days of this cold streak that was happening. So with this happening, the generators were not prepared to support the amount of electricity that the citizens of North Texas was using. So since the generators weren't able to support the energy, the generators exploded. And since the generators exploded, this cost Texas millions and millions of dollars. And not only did this cost Texas millions and millions of dollars, citizens lost their homes. They were without electricity. 5 million homes and businesses were without electricity. And this was all simply because their generators were not prepared to sustain the amount of electricity they were having to give out. And for my next section, I'm going to go to where's the section? Section electric vehicles. And for this main point, I have electric vehicles can be the future of transportation. As of 2021, there are 60,000 new battery remote electricity cars made, and I think the number could keep increasing as we are trying to find different ways to get more electric cars. Although they're expensive, they're very beneficial, better for the environment, doesn't take gas, able to charge. So overall, I think in the future, I think we'll see more and more electrical cars as our technology continues to advance. And now I'm going to talk about my figures and then the main point of the sections. So for my figure to the left right here, we have the global use of energy, the global use of electricity and hydrogen use from the year 2010 estimated into the year of 2050. And just looking at the picture, you can see electricity definitely got an earlier start than hydrogen, as they don't expect the hydrogen use to pick up until about 2030, but we can see that the electricity has been on the rise since 2010, and they only believe it will continue to go up. And then to the right but left on the screen, we have what is called the duck demand. And so what the duck demand is, it gets its name because it looks like a duck. So the blue on the duck is going to represent the back. So the blue line at the top screen, that's going to represent the back. The brown line is going to represent the stomach of the duck. And so this just kind of shows the use of electricity throughout the day and a normal day of California. As you can see, it's pretty stable, and in the evening you start to see a decrease in the electricity. And for my final picture, figure 3, demand for electrical power. You can see it's based off of hours in the day, so we can see clearly once you get towards the nighttime, you see a big drop off in the use of electricity. And for the whole section in a whole, I have the main point as the main point of this is that energy can be transferred in many ways and can be put out in many ways. And what I mean by that is there are many different ways to get energy, and there's a million different ways of putting it out. So for example, like I was saying earlier in the first section, fossil fuels is a way to put out energy, but solar power is as well. So I just felt like that was overall the main point, is that there's different ways to put out electricity and to receive energy.